Hey folks, so today actually we're going to be going through this problem called longest palindrome subsequence. I thought it would be a good idea for us to kind of like look into the concept of subsequence as well as substrings. So this will be beneficial for us so that when we get questions related to subsequences or substrings, we know specific techniques that we can use to approach those type of problems. So yeah, in the next video I'm gonna look at the same problem but related to substring. Anyway, we are told that we are given a string and we need to find the longest palindromic subsequences length in S. Before we approach this problem, let's try to understand these concepts first. So let's start with palindrome. So palindrome is nothing but it's essentially a string that when you reverse it, it still reads the same, right? For instance, let's say we have a string like A, B, A. So if we reverse this, like we take A, we put it first, we take B, we put it here, we take A, we put it here. So we reverse this, but they're still the same. As you can see, they still read the same. But if we take a string like something like hectare and you try to reverse this, like you take ROTCEH, they are not the same. They are not the same. So this is going to be false, whereas this is going to be true. So in simple terms, palindrome is just a string that reads the same when you have reversed it. So now the second concept that we need to understand is the subsequence. Also, a subsequence, you can think of it as a sequence that is derived from the main string, right? Even if you deleted certain characters, so that's but it still have to maintain the order. So just to kind of like explain this in a much more better way. So let's say we have a string like hectare, right? So if you take H, this is a subsequence, still fine. If you take E, like you say HE, this is a subsequence, that's fine. If you take HC, this is a subsequence, that's fine, right? So essentially, a subsequence is that even if you delete this and you can just take any characters, but you have to maintain the order, meaning that you can't say RH. No, that's not the order. Like you started here, you're going backwards or something. No, you have to maintain this order, like going forward, like right. So you can take HTR, that's fine. HTR, because of you took this, you took this, you took this. So you're maintaining the order. That's what a subsequence is. You can delete the, you can skip some of the characters, it's fine. But as long as you take those characters and you still maintain the order, that's definitely fine. Okay, so I needed to kind of like make sure that you understand that. But that's what a subsequence is. So now, given that we have understanding of what that is, so let's try to read what this question wants again. So we're given a string and we need to find the longest palindromic subsequence length in S. So we need to find the longest, right, palindromic subsequence. So what this means is that we have let's make an example so that we understand this question better. So we have a character here. We can see a string which is B with B with B with A and we have B. So we need to find the longest palindromic. So we do know that, okay, this is, we said that this is a subsequence, right? So B is a subsequence. BB is a subsequence. BB is a subsequence. BA is a subsequence. But we need to find the longest palindromic. So the first question that I'm going to ask you is that, okay, because of this is a subsequence, it is a palindromic also. You're going to say yes because B, when you read it backwards, you, even if you reverse B, it's going to be a palindrome because of, even if you reverse this, it's just going to be that, right? We're looking to BB. If you reverse this, yes, it's a palindrome and it's subsequent. Yes, that's also a valid, right? So if you take these three B's, like for instance B, 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 yes, they are also subsequent. and they are a valid palindrome, because if you reverse this, it's a palindrome, it's true, right? But what about this? So BBA. So BBA, right? So we can see that this is a valid substring, yes, but it's not a valid palindrome, because of if you reverse this, it's just not gonna read the same. It's not gonna be the same, right? So um but the question said they want the longest. So we have these valid stuff, but they are not the longest, right? So what we need is that we need the longest. So in this case, the longest will be if we take B, 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 and B, right? We take this, we take this, we take this, then this will be a subsequence. And if we check if this subsequence, it's a palindrome, meaning that if we reverse this, it's going to read the same, and it is. So this will be the correct answer. So that's why here we have 4, and I think they made example that this is the correct answer. So I hope this kind of like gives you a better intuitive how you can think about this. So how can we go about this, right? So what I will say is that let's think about the most brute force solution, right? Like this is not an efficient solution, but it's more like what comes to our mind, like right. So we saw that okay, the first thing that we can do is that we can actually generate the subsequence, right? We can say given a string, generate all the subsequence, right? We know what the subsequences are, then we can say, okay, now that we have the subsequence, let's actually check um, if those subsequence that we generated are palindrome, right? A palindrome. Then, as well as like we just keep track of the max, like the max length of that, so that we can actually return, right? We just keep track of that. So we check the palindrome. Okay, there's this subsequence. When we read it in reverse, is it still the same? Is it longest than what we currently have? Then we're gonna keep it, right? Because that's what we're gonna return. That's how we can actually solve this. But the question that comes to your mind might be, wait, but how do I generate subsequence, right? It's like, if like we have a string like ABC, right? We know that A it's a valid subsequence from this, right? We know that what is it, AB, it's still a valid subsequence. We know that AC still a valid. We know that B still a valid. We know that BC still valid. We know that C still valid. You can see that you can pick anything as long as it keeps the order of the string. It's fine. You can keep any you can pick anything like AC. It's fine as long as they keep the order. It's okay, right? And you can skip any characters. It's fine. You can skip. Whether you skip A, it's fine. B, C, that's how you do it. But how can we generate something like this? So we can use recursion. So the good thing with recursion is like it's a tree, right? So you can tell recursion that okay, you know what? Pick the first character, or do not pick the first character. So you can have more like a decision tree that you do. Like okay, like when we start at A, right? You can pick A. When you pick A, you say okay, I'm gonna put A here. Then you move to the next index. You increase your index plus one. You say plus one. So your index is going to move to B. You can also make another decision here. You can say, do we pick B or not? Let's say you say, okay, you know what? I'm going to pick B. That's fine. You pick B. Okay. Then you increase your index, right? Then you can come here and say, um, you increase your index. That means you're going to come to C. You say, C, do I pick you or not? Right? It's also a decision that you can make. So you can pick C. Then your string will be ABC, right? So that's one. That's you generated a subsequence. That's valid, right? But let's say you didn't pick C. That means that you did not pick C. That means that you're gonna have AB. That's where your length end. So you're gonna add AB. That's still fine, right? Let's say at this decision, because of you at this decision, you were supposed to pick between you were supposed to pick between B. So you picked B, but let's say you took this decision and you say, you know what, I'm not gonna pick B. That's fine. That means that you have A. So A is a valid thing. So you see, like, that's how recursion work. So how you can write this from code perspective is that you can do something like this. You can have a function whereby you can say, generate subsequence, right? Subsequence. So then you can take a string. Maybe you can have this current, which is an empty string, so that you can keep track of the current, the generated strings. Then you can keep an index at 0 because you're gonna keep on incrementing it. So when you get to the base case will be that when your index reach the length, we saw this, right? When it reaches the length like of s, then you can say, you know what, I'm gonna print the generated subsequence, which is current, like so, right? Then you can call this function because it's a recursion, a function that calls itself. So you can say generate subsequence, whereby you can say, okay, this is my s, but then I'm gonna take, I repeat, you're gonna take the current character. So you're gonna say, okay, s at current index, I'm taking you, then I'm gonna add you inside the current. Then I'm gonna go to the next index, index plus one, right? And we saw that we have another decision that we can take. So the another decision that we can take, we can call our function, we can say, okay, there's a string, but we're not gonna take any character. So we're gonna keep our current as it is, but we're gonna move to the next index. So that's how you generate subsequences. And then you can then call this palindrome function. So to generate to write a palindrome function is also quite simple because um, you can just reverse a string, right? So you can say you're given s, then you're gonna say reverse s, right? Reverse s, is it equals to s? So this is gonna return true or false, right? You call the reverse function, then you say after I reverse this, uh, is it equals to s? So this is gonna return true or false. Okay, that's how you can solve this problem. That's like the brute force way. We thought us actually thinking about optimized way, but now we have to talk about the optimized solution. So let's try to optimize this, right? So we know that we're given the string b b b a b. Okay, this was called as, we're gonna call it s1. So let's try to reverse the string. So the first thing that we can do is that, okay, we can say this will be b a b b b, right? So this is not a valid palindrome, but what we can do is that we can turn this problem on its head and we can say, can we find the longest common subsequence, LCS, right? So what does that mean? It means that given to string, we're gonna find the common subsequences, like, right, that pretty much are the same from those two strings. So for instance, let's make an example. um, if we have b here and we have a b here, so these two characters are the same. So this is plus one, right? Then you're gonna move these two pointers to the next character. So you're gonna bring this pointer here, you're gonna bring this pointer here. So you have B and A. So these are not the same, right? But because of this, the definition of subsequence, you can skip any of the characters, right? You can skip any of the characters. So what will happen here is that we can say, okay, you know what? We can make a decision that we're gonna skip this guy here. So we're gonna come here, right? Does this B and this B are the same? Yes, they are. So this is gonna be plus one. So we're gonna move the both pointers. So we bring this pointer here and we also bring this pointer here. We ask ourselves the question, does this B and this B are the same? Yes, it's a plus one. We move both the pointers, we bring the pointer here and we bring this pointer here. Is this A and B the same? No. So we can move any of the pointers. Whether you want to move this is fine. Whether you want to move this is fine. But the punchline is that um, you have to find something that they're the same. So it's a recursion. So let's say we move this one. It's fine. Then you ask the same question. Is this and this the same? Yes. So it's a plus one. So then your pointers will run out of bound. It will be out of bound. So this is going to be an edge case. So we can see that we got four. So this is correct. This is what we got previously. But the punchline is that we reversed the string and then we try to find the longest common sequence, right, from these two strings. And this is how we're going to solve this problem, because now we can use the memoization technique whereby we can reduce the term simplicity from quadratic to S1 by S2. So let's go into the code and look into how we can. So now looking into the code of this problem. So the first thing we're gonna do, we're gonna reverse the string that we're currently given, so that we can be able to turn this problem into more like a longest common subsequence. So the idea is that we're gonna try to, if we know that if we find the longest common subsequence, then that is going to be our longest palindrome subsequence. The reason that's the case is because of we have reversed the string, right? Remember that palindrome, we said that it's a string that reads the same if you reverse it. So that's what we do, is that we reverse this, then we're just gonna find the longest common subsequence like I showed you in the black board, right? So because we're using the DP technique, so we're gonna use memo so that we can reduce our time complexity from quadratic to what is it, S1 and S2. So what we have here is that we're going to check if the index of the first string it is out of bound, or if the index of the second string it is out of bound. If either of them are out of bound, we're just gonna return zero. So that's what we're gonna return. So this is the case whereby I said that as you move in your pointers, like your index one and index two, if it happens that the current pointed characters are the same, right? You're gonna increment. That's plus one. If they are not the same, you have two options to make. It's either you can move the first pointer or you can move the second pointer. So that's what you can do. Like you move the first pointer, index one plus one, index two plus one, right? Then you're gonna choose the maximum path that you took, because you're looking for the longest palindromic subsequence. So you can choose the longest. Okay. Then this is just when you're gonna return the final result. So this is just like caching mechanism, because we don't want to repeat the path that we have already taken. If you are new to this concept, I know they might sound very, very hard for you to kind of like wrap around your head around, like what is memo, what is DP. I'll probably link a link uh, in the description below, whereby I think this course was covering the fundamental of dynamic programming on free code camp. So I'm sorry for not covering like the basics. So I think I like to kind of like cover the problems themselves. Anyway, this is the solution, and that's how we kind of like solve this problem. Thanks. I'll see you guys in the next one.